Hello, can everybody hear me? Hi. I want to welcome all of you to our opening exhibition, or our opening reception for the exhibition, Biophilia in Excelsis. I'm really thrilled to have all of you here. I'm especially thrilled to have all of our panelists here. So my name is Ryan Darr. I'm a postdoc here at the ISM, and I'm going to be just introducing our curator, Annenberg, and then getting out of the way. But before I do that, I just wanted to make a couple quick announcements. One is that I want to make sure everybody knows that this event is part of the Yale Institute for Sacred Music's Religion, Ecology, and Expressive Culture initiative. This is one of a number of events we're doing throughout this year, and plenty more in process continuing into next year. So I encourage you to check out our website. You can find all the information at ism.yale.edu about upcoming events. I also want to mention one of those events that's not yet up on the website, which is a closing webinar for this exhibition. So on May 1st at 5:30, we'll have a webinar discussing broadly religion, arts, and ecology, featuring our curator, Annenberg, Paul Miller, aka DJ Spooky, will also be part of that. And in addition, we'll have Timothy Morton, the eco-philosopher, and Richard Festinger, the composer with the Climate Music Project. So please keep an eye out for information about that. And thank you. And finally, I just want to make sure everybody knows there are more snack boxes out in the lobby. You're welcome to eat those in here during the event. That's what they're for. So if you get hungry, please help yourself. Okay, so I'm going to introduce our curator. Annenberg is a conceptual artist and independent curator. Her paintings, sculptures, and installations and videos focus on underreported stories in American media, concentrating on scientific studies and global warming. Annenberg's recent artwork deconstructs the reporting of 5 major climate studies: the Emissions Gap Report, the National Climate Assessment, the Paris Climate Treaty, the UN's 5th IPCC report, and the Hindu Kush Himalaya Assessment. Her paintings are in the permanent collections of museums in Lithuania, Israel, England, and the US. She's organized 6 environmental exhibits, including Petroleum Paradox, Earth SOS, which was co-curated with Eleanor Flomenhoft of the Flomenhoft Gallery, Endangered Earth, Earth on the Edge, and Mayday Earth. She's also done pop-ups at the Saris Gallery in New York City, and now this event here tonight. So we're really thrilled to have her here, and I'm going to let her take over and introduce the rest.
Thank you so much, Ryan, and thank you so much to the ISM committee for including Biophilia in Excelsis as part of your proposal for a Ritual Natures. I'm so happy to see all of you. Thank you so much for coming. This exhibit, it's an honor and a thrill to be here with you. Thank you to all of my artists who also share my passions for saving our ecosystems. Some of you have been with me since 2012 when I organized the exhibit Petroleum Paradox. Biophilia is Greek for the love of life, and in Excelsis is Latin, meaning in the highest. In Excelsis comes from a piece of music I sang in high school called Bach's Magnificat when I was a music major. The whole phrase is Gloria in Excelsis Deo, glory to God in the highest. Unconsciously, I deleted the word Deo or God from the title because, according to many indigenous beliefs, nature is sacred. The artists of Biophilia hope for a re-enchantment with the exquisite beauty of the earth. We pray for a culture that honors the innate connection of all of the species of the earth. Before beginning the panel, I want to remember the artist Janet Culbertson, who passed away in October. She was a pioneer of ecological art. The green painting on the wall, called Clear Cut, was done in 1970, 50 years ago. Let's take a moment also to remember the non-human species that have passed away in our warming atmosphere. At 1.1 degrees of warming, 3 billion creatures died in the Australian wildfires. The next year, 1 billion sea creatures boiled to death off the coast of Vancouver when a heat dome brought the temperature of Canada to 120 degrees. This summer, several colonies of emperor penguins perished on the disappearing ice of Antarctica at 1.2 degrees. The question is, what are we willing to lose? How much loss will we accept? The artists of Biophilia understand that to accept a goal of 1.5 degrees is to accept a goal for the continuing decline of species, an overheated planet, a disappearing cryosphere, and the degradation of our oceans with the loss of most of our coral reefs. The artists of Biophilia reject that goal. May this exhibit inspire action as we witness in real time the imperilment of all that we treasure in the natural world. Picasso said, "Painting is not done to decorate apartments. It's an instrument of war for attack and defense against the enemy." The paintings in this room are part of the battle against indifference, apathy, and greed. The artists of Biophilia describe our endangered phytoplankton, our warming oceans, our endangered species, and the destruction of our rainforests. We manifest the science of global warming in visual form, and the science is urgent. We know that there is an ongoing attack on climate scientists. The weapon of that war is the silencing of science, and there has been no scientist more silenced than Gavin's predecessor, Dr. James Hansen. True confessions, Dr. James Hansen is my hero. Sorry, Gavin. I went first. Dr. Hansen's arrests, protesting Keystone XL, which he called game over for the planet, were barely reported. I discovered a photo of Dr. Hansen in handcuffs on the internet on a website called Tarzan's Action. The photo was taken by Ben Powless. What if Ben hadn't been there? Would there have been a visual record of Dr. Hansen's arrest? Why was our chief climate scientist getting arrested in 2011? What did he know that the rest of us didn't? My own artwork documents the underreporting of climate news. And to me, the most egregious omission in our news was Hansen's talk to Congress in 2008. It was the 20th anniversary of his infamous 1988 warning. Photographic evidence shows that the room was packed. Reporters were present, and yet America's newspaper editors silenced that talk. I found Hansen's remarks in a British paper called The Guardian. Why was his talk a secret in this country? Because Hansen called for the arrest of the CEOs of our oil and gas companies for degrading Earth's atmosphere and oceans. He said, and I quote, "They should be tried for high crimes against humanity and nature." How many people know that we have changed the chemical composition of our biosphere? Why couldn't the American people hear that speech? To conclude, it's important to know that Media Matters, an investigative group, found that in 2022, only 1% of all broadcast news on ABC, CBS, NBC, and Fox covered our climate crisis. Only 1% of reported news. Let me remind you what happened in 2022. 1/3 of Pakistan was underwater, and conversely, 3 river systems dried up all over the world: the Yangtze, the Rhine, and the Colorado. In 2023, it was less than 1% of broadcast news, even though Canada lost 4% of its boreal forest to fire. This discrepancy between reality and reported news is a red flag. We're living in a time when authoritarian leaders are on the rise, and the silencing of science, like a canary in the coal mine, reveals that a democracy that should be based on a free press has already been compromised. Our free press has been compromised. In the gray area of truth and lies that dominates our media landscape, it's invaluable to hear firsthand from a climate expert on the true state of our planet. And I'm so happy that Dr. Gavin Schmidt could join us today. Dr. Gavin Schmidt is a climate scientist and director of NASA's Goddard Institute for Space Studies. He's also an adjunct researcher at Columbia's Earth Institute, working on understanding past, present, and future climate change. He is the principal investigator of the GISS Earth System Model. His 2014 TED Talk on climate modeling has been viewed over 1 million times. Thank you, Dr. Gavin Schmidt, for being here with us. Ryan, I want to take this to my seat. I'm having trouble
Hello?
getting it out, Gavin and I met many years ago, 12 years ago to be exact. And we met at a public lecture at the Earth Institute. Gavin, your lecture was about a term I had never heard of before and have not heard of since. True. The topic was climate inertia. Please tell us, what is climate inertia and why should it matter to us?
So first of all, thank you very much for inviting me here. You know, this is a great opportunity to kind of talk about science in a very different audience than I normally talk about science, and to learn about art in areas where I often have a lot to learn. So thank you again for hosting this. You know, I think you know, climate inertia is both a reflection of the physics of the climate, you know, so there are a lot of big things in the climate system, like the oceans are very big. They take a lot of energy. They're like icebergs are very big, ice sheets are very large. And it takes a long time to get things to move, right? Inertia is that tendency to want to just stay where you are, doing what you're doing, and you know, a resistance to being pushed around. And the Earth's climate is, in fact, quite resistant to being pushed around, to being moved. But we've been very insistent as a species. And our efforts to move the climate along into effectively a new state have been successful, unfortunately. And you know, initially this was not deliberate. You know, we were not deliberately pushing the climate, but we have known for now 40 years that we are doing so and that we're going to continue to do so. And so the notion that this is now accidental probably goes by the wayside. But that inertia has both good and bad aspects, right? So it's good that it takes a lot of work to push the climate away from where it was, but it's bad because it takes a long time to kind of move it back again. And so everything that happens in the climate, let me not quite everything, but a lot that happens in the climate happens kind of slowly, and you know, it doesn't change from day to day, but the impacts of those changing climates are indeed felt in those everyday things. And then once we're there, and once we're in, I mean, people have called it a new normal, but that would imply that we've kind of got somewhere and we're going to stay there. We're not going to stay there. We're going to keep on moving while we still keep emitting greenhouse gases. We would have hoped for more inertia, but we don't have enough.
That sounds disappointing, actually.
Sorry, I'd like if you told me that you wanted me to bring like a good news story to this audience, we would have prepared a totally different set of questions, I think.
Well, that's a segue to my next question. Ecologist Dr. William Ripple circulated a petition to 15,000 scientists declaring a climate emergency on Earth. Do you agree that there is an emergency, and if so, why?
I don't really know. I mean, I know this person. I know their work. It's not really that well based in physics. I mean, his heart is in the right place. You know, he wants to do things. He wants to get people motivated and energized and mobilized to do something about emissions. All of which is fine and creditable. But he sometimes he kind of goes overboard in terms of what he claims that we do or don't understand. And so like scientifically, he's not really coming from a place of great credibility. Should we declare a climate emergency? I don't know. I mean, places have declared a climate emergency, and it's not obvious that they're doing anything better or worse than any of the other groups or societies or towns and cities or states that have not done so. So is it motivating? Is it? That's a question that one should ask a political scientist as opposed to a climate scientist. So I don't know whether that is a worthwhile effort. But I don't know what the worthwhile effort is, and so I'm happy to let 1,000 flowers bloom, and maybe one of them will be the thing that actually makes a difference.
Well, how do we transition to a new energy system if it's not urgent?
Oh, I didn't say it wasn't urgent, but we have to transition things away from internal combustion. We have to transition away from coal and natural gas, because those are the absolutely number 1, 2, and 3 sources of climate change. And so we have no chance of even slowing what we're doing if we do not tackle those things as a matter of urgency.
So is it a matter of semantics, urgency, rather than emergency? I mean, is that a semantical question?
I mean, it's a question of how things move. How does society change? How do you make society change? How do you accelerate change in society? And lots of people have lots of ideas. None of them have matched the moment with respect to climate as yet. But I don't know the answer, unfortunately. My role, my expertise as a scientist is in diagnosing what is happening and why, and then making predictions for what's going to happen, under various circumstances in the future. But that information doesn't give me any more insight into how to move a society of 8 billion people in a more sustainable direction. That's a much bigger task.
But certainly science could advocate for closing coal plants all over the world.
One can easily say, yes, coal plants are the biggest single problem, and you can get off coal. So I think in the UK this last year, they used less coal than they had done since 1780. Right at the dawn of the Industrial Revolution. So if the UK, the cradle of the Industrial Revolution, can get off coal, everybody else can too.
That's helpful. Next question. NASA's satellites, the OCO2 and OCO3, or Orbiting Carbon Observatory, can measure and pinpoint sources of CO2 on land. A team of scientists recently analyzed the amount of CO2 burned at a power plant in Poland, the Bełchatów power station, from data received by the satellites, and it correlated with studies of expected emissions. According to a Yale study of the American population, 15% of Americans are not sure whether global warming is caused by nature or is caused by the burning of fossil fuels. Do you think it would be helpful if the news industry did feature stories on the reliability of these satellites for this segment of the population?
So, I work for NASA, and one of the greatest things that we do is we observe the planet from space. We have more than 24 instruments flying right now over our heads, on polar orbits, tropical orbits, some of them geostationary, measuring everything, almost everything that you can think of: the sea level, the temperatures, the ozone, the winds, the sea salt, the dust, the methane emitters, the carbon dioxide, lots and lots and lots and lots of things. Without those eyes on the Earth, we would be flying blind. We would not know what was going on. But we do know, right? We've built this massive set of machines which don't last forever. We have some there that have been, the OCO2, that stopped working after a while. OCO3 is on the International Space Station, looking down from those orbits. It's an incredible feat to have put so much stuff in orbit. It's an incredible enterprise to interpret that information. And then to embed it in our models and use it to make predictions, and use it to make we use it for emergency management. We can track flooding, we can track fires, we can track land degradation, deforestation. All of these things can be viewed from space with a timescale of the last 50 years. Like we have Landsat imagery literally that goes 50 years, and you can see so much change. Not just in the climate, but in our environment, in our cities, in what we do with our cities, and it's an enormous thing. And so should we talk about that more? Absolutely. Should that be on TV every night? Absolutely. Do people actually enjoy seeing it? Yes, they do. People are fascinated by the triumphs of our technology, even though it's telling us things that we are less comfortable with.
Excellent. So if there are any reporters from covering Climate Now in the audience, please contact Dr. Gavin Schmidt for a story on the satellites. Last question. Yeah. An acquaintance of mine, who is a climate denier, said that scientific data needs to be observable and replicable, and that climate science is neither. In your recent NOAA-NASA media conference, your colleague Russ Vose mentioned 4 other sources for climate data: the Copernicus Climate Center, the UK Hadley Center, Berkeley Earth, and the Japan Meteorological Agency. How does NASA work with these other agencies to verify data?
So your friend is making a good point, but he's not really arguing in good faith, and I'm assuming that he's a he because it's mostly men that do this. Science, we do want to replicate things. There's lots of the history of science is replete with observations that would be incredible if they were true, but didn't actually turn out to be replicable. It turns out to be something wrong with the instrument, or something wrong with the procedure, or somebody making up the data. So absolutely, the science that we need to do needs to be repeatable and replicable and independently verifiable. Absolutely, but it all is, right? We have multiple groups around the world. You mentioned some of them, keeping track of temperatures on the surface. We have satellites viewing these temperatures independently, totally independently. We have weather forecasting systems that make an estimate of these things independently. All of them are telling us what's going on. We have no doubt about the warming that we're seeing. And we can see it in all of those other things that are affected by the warming. We can see it in the melting of the mountain glaciers, the loss of mass from Greenland, from Antarctica. We can see it in the shifts of the hardiness zones. If you're an amateur gardener and you're planting things, right? The USDA is moving the hardiness zones, slowly but surely. Every 5 years, you're in a different zone because the climate is changing. New York is now subtropical, right? It didn't used to be. Things are shifting, and you don't need a weatherman to tell you which way the wind is blowing.
Actually, there was one quick last question. Quickie. Dr. James Hansen released a study indicating that global warming is accelerating. Dr. Michael Mann appears to disagree. What's your take on the subject?
So Mike's my friend, Jim is my friend, and my former boss. I don't talk about these things in public. No, I mean, so the main issue is, things have been kind of moving along like this. Last year was very special, and not in a good way. 2023 was the warmest year on record, but it was warm in ways that we are not totally clear about. I just had a piece in Nature this week talking about how weird this was and why it didn't fit any of the previous patterns that we've seen. So it was weird. Now, is that weirdness because it's a blip and lots of things just all kind of lined up and next year we'll be back to kind of climate as normal? Or is it presaging something different changing? With just one number, with one data point, it's very hard to say. And so I'm pretty agnostic, and I don't really see how anybody can be very definitive about what that means, given that it's just one data point. This year, let's see what happens. If it kind of these last few months have been very warm because on the tail end of the El Nino event that's been happening in the tropical Pacific. But if things stay super warm all through the summer and the fall, okay, then something has definitely changed, and that would weight things towards Jim's argument. If things kind of go back to as expected, which is still warming on a decade by decade basis, then I think we'll be looking to explain 2023 as maybe a combination of very unusual circumstances. But right now we don't know, and that's disquieting because we have had up until now a very good handle on what's been happening and why. Because of all that data, because of all that statistics, because of all that understanding. And 2023 surprised us. And we don't like being surprised, as scientists and as a society. I don't think we should want to be surprised by what's happening in the climate. And so that's disquieting.
Definitely, if you're disquieted, I'm really disquieted. Okay, moving along to our first artist speaker, Susan Hoffman Fishman.
I'm going to go up there.
Okay. Do you want
because I can't
do you want this thing?
turn and talk at the same time.
Susan Hoffman Fishman is a Connecticut-based painter, eco-artist, and arts writer whose work has been exhibited widely throughout the United States in museums, galleries, and public spaces. Since 2011, all of her mixed media paintings, installations, and writing have focused on water in the context of climate change, including rising seas, water pollution, and the proliferation of sinkholes around the world. She's especially interested in the contrast between the destruction of our waterways and oceans and the magnificent beauty of that destruction.
Thank you, Marcia. This one?
Does she have either one? Either one? Oh.
In 2020, I had the great fortune to be an artist in residence at Planet Labs in California. And given the free reign of all of their satellite imagery, they are a company that provides, like NASA, satellite images of every place on Earth daily. It's used by scientists. I think NASA scientists use it as well. And what I decided to focus on was changes to bodies of water that have been impacted by climate change. The first body of water that I looked at was the Dead Sea. The Dead Sea borders both Israel and Jordan. This image shows the dramatic changes that have occurred to the Dead Sea over the last 70 years, 74 years. And what I noticed when I looked at satellite images and at drone images was that there were these unbelievable holes all over the Dead Sea. And I asked the geologist that I was working with if she was aware of this, and she said no. So I did some research, and I determined that there are over 8,000 sinkholes now surrounding the Dead Sea. And what has happened is that as the temperature increases, the water evaporates more quickly. Also, there is a Dead Sea Works company at the lower part of the Dead Sea. You can see it sort of at the green in the 2000 area, image. And that company extracts a lot of water daily for their cosmetics industry. And also the Jordan River, which used to flow into the Dead Sea, has been dammed for irrigation and other uses. So the Dead Sea is not getting any fresh water. So I decided to do a series of imagery based on this phenomenon. By the way, when I talked to the geologist I was working with, she was astounded at the facts, and she said, usually geologists study things that happen over eons. They don't see these kinds of things that are happening in a person's lifetime. So this is, it's not my work, this is a drone image of several of the sinkholes in the Dead Sea. And you can see just how astoundingly beautiful they are, even though they show immense devastation. The colors in the sinkholes are gorgeous, and that is because of the minerals that are in the water that remains in the sinkhole. This is one of the first paintings that I did on the Dead Sea sinkholes. And what I wanted to point out to you is that I did start also to do cyanotype prints of the satellite images, and you'll see some of them within the sinkholes themselves. But the colors that you're seeing are true to what the satellite images have shown. This is tricky.
Want me to try it?
This is another image of the Dead Sea satellite images. And what's at the top is the sea, and that is a direct cyanotype print of the actual sea itself.
Should we go to the next one?
Yeah. I moved on to other bodies of water. This one is the Aral Sea. I think some of you have probably heard about the Aral Sea. The Aral Sea is about 40% of its original size. And the reason for that is because the Soviet Union decided, I can't remember the date, but not that long ago, to develop a cotton industry in the middle of Central Asia. And they used all the water in the in the Aral Sea to irrigate the cotton, you know, in a desert climate.
Next.
What is the actual width in feet or miles, the actual between the left and right of that picture?
It's a painting.
A mile?
Oh, you mean how big is the image?
Yeah.
Oh, the image itself is like 30 by 30 inches.
No, on the land. What is it, the image of? How big is
On the satellite.
Oh, it's,
the actual on the land that you're making the image?
I don't know the answer to that. I'm not sure. Did you skip one?
No.
Okay. Another image of the Aral Sea, and this time you get a sense of how dramatically the sea has changed, because there are actual images of these ships that have just been rusting on the sea in areas where the water once came.
That's it, Susan. That's the last image. Thank you so much.
Yeah.
Next artist is Eleanor Goldstein. Eleanor Goldstein is a painter and sculptor from New York City, working in a variety of mediums. She's a member of the National Association of Women Artists and the Upstream Gallery in Hastings, New York, as well as a signature member of the Pastel Society of America and a member of the New York Artists Circle. Goldstein is a Wurlitzer Foundation Fellow. Her work has been commissioned by the Cathedral of St. John the Divine, New York City, and selected by the United States Art and Embassies Program, and she's exhibited at the Rockefeller Gallery in Pocantico Hills, New York. Eleanor.
That's okay. Do I speak from this?
Yes.
Okay, can you hear me? Okay, thank you. First, Marcia, thank you. You brought the dream home, and it's really very wonderful. In approximately the last 8 years, I've taken 3 trips to the Arctic Circle. The first time on a fishing trawler to Greenland, the second time to Greenland alone, and then third and most miraculously with my poet friend there also on the Antigua, which is a sail ship. And you have to think of Gilbert and Sullivan type sail ship, because that's precisely what it was, with an ancillary motor in case a storm chased us off into another part of the coast. That was or a archipelago. Oh dear, forget it. That was northwest of Norway. In, where was it? Pronounce it for me, darling. Svalbard. She came with a helpful hand. What am I as an artist, and why did I pursue this? There is nothing in this world that we have ever experienced like the Arctic Circle. It is, if you want true silence, where the only noise that is not made by nature beyond you is to be there. The loudest noise I heard outside of me or inside of me was my breathing. I could also hear the clothes I wore move against my skin. It's an extraordinary place, and I have always, as an artist, searched for that which is like a ballerina standing on toe shoes, not quite in full arabesque yet, tilting. And so our earth is tilting. And the call to catch it and to honor it and to pass it on is why I went back and will again go back to the Arctic Circle. And so these are some of the landscapes. I choose the medium that best expresses it. Oh, On the last trip to Antigua, I could not paint watercolor outside to catch the moment. The water froze. So I was told, add a little alcohol. Vodka did not make it work. So, in honesty, the Antigua was less than 40 occupants, including captain and cook. We had painters, poets, musicians, all seeking the connection with the earth, so that some of the artists put recorders into the earth because the earth is crying, and they incorporated that into their videos and musical compositions. Others picked up the pigments, volcanic ash and permafrost, and would take it back and mix it with their mediums. My art here is simply to do honor and to mourn and to hope, dear God, we save some of this for who we leave behind in the coming generation.
Thank you so much, Eleanor. Thank you so much. Eleanor's work is so remarkable because it's more than a landscape. She actually captures the emotion of silence and loneliness and mystery. It's so remarkable that it's more than a landscape. It's an emotional experience. Next artist is Paul Miller. Paul Miller, also known as DJ Spooky, is very simply a Renaissance man. He is currently artist in residence at Yale University Center for Collaborative Arts and Media. He is a composer, multimedia artist, and writer whose work engages his audiences in a blend of genres, global culture, and environmental and social issues. Miller has collaborated with an array of recording artists, including Ryuichi Sakamoto, Metallica, Chuck D from Public Enemy, Steve Reich, and Yoko Ono, among many others. His 2018 album, DJ Spooky Presents, Phantom Dancehall, debuted at #3 on Billboard Reggae. Thank you so much, Paul, for being here.
Okay, so first and foremost, Marcia, thank you so much for curating this, and I also want to say thank you to the Institute for Sacred Music. It's been an absolute pleasure working with them. So I'm going to begin. This is my piece in the exhibition. I usually work at larger scale, but I did a smaller piece because you want to work with the context. So this is a collage of both the Arctic Circle and Antarctica. I spent 6 weeks in Antarctica in 2011 and did a book called The Book of Ice, working with the renowned physicist Brian Greene, whose book, The Elegant Universe, is, to me, an all-time classic. Essentially, the title is called Fractal Apophenia. Apophenia is a Greek term that means, basically, it's a tendency to see meaningful connections between unrelated things. So here we are in the 21st century, and data has become sort of the folk culture of how we think about narrative. And for me, at least, photography, multimedia, and the digital arts have become kind of the new commons. The ancient Greek term, the agora, comes to mind. So the places I went in Antarctica, documented in the book, and then did a series of video essays about that. And I want to begin with the conversation thinking about this notion of cultural capital. Milton Friedman, the economist, did his PhD on this culture in the middle of the South Pacific called YAP, Y-A-P. And in YAP, this is a currency. That's a big money. If you basically, if you did a trade, if I traded you a cow for 15 coconuts, we'd have about 20 guys show up and drop one of these. They're called rye stones on your front lawn, and that would be the transactional marker of our social ledger. So you could call this sort of Stone Age Bitcoin. And to me, what's intriguing about this is it's a kind of a marker of cultural capital. And in our time, there's two words that come to mind with the climate crisis that inspired my piece. One is, of course, economics, and the other is ecology. Both derive from the Greek term ekos, which means place of home, or the place of where you dwell. Economics Nomos, for example, again, and logos, those are two terms that sort of structure our relationship to the aesthetics. Again, these are all Greek, Aristotelian logic here. But when you're in the South Pacific, this idea of cultural capital, to me, resonates with some of the issues of our time. And that's one of the things I was grappling with when I was working on the photography and exhibitions from Antarctica and the Arctic Circle. The book, like I said earlier, was called The Book of Ice. This is one of the untreated photos. It's a synthesis of two different terrains, north and south. And you'd be very hard pressed to tell where it's from unless you can really think about glaciers as a kind of a metronome, a marker of time. And as a composer, the notion of the Earth as a pattern recognition system and how humans interact with those patterns inspires my work quite a bit. So the book, I had a series of essays by different physicists looking at pattern recognition in nature. I'm very intrigued with that because also, as a composer, patterns are how we derive our thoughts on composition. The album that I made is called Of Water and Ice, and we had the premiere at the Metropolitan Museum in New York. And all the songs were projected through different kinds of ice. And if you think about ice, it's a geometric form, and it's based on, again, how nature thinks of itself as a tuning system. One could argue, when I say nature thinking of itself, that's kind of it's a paradox there. There's obviously an unmoved thinker, again, going back to Aristotelian logic here. Now, why I'm kind of riffing on Aristotle versus Plato and the idea of forms is that ice is one of the most mathematical structures in nature. So what I ended up doing was taking some of the weather patterns and looking at the temperatures and the temperature differentials when I was there and doing what you call a algorithmic music transcription. The idea was to transpose the weather patterns into electronic music, and we had a series of concerts that went through different museums around the world. And so the photography is about, again, distilled patterns and then using the pattern as what I like to call an acoustic portrait. So it's not just an object, because that's very 20th century. In the 21st century, we have these ideas of intermodalities. Graphic design speaks to digital media speaks to fonts, speaks to algorithms, speaks to different kinds of mathematic structures, and of course now we're in the era of large language models, and AKA artificial intelligence, which I don't believe intelligence is very artificial. So, all right. So I'm going to go to this gentleman, Gottfried von Leibniz. If you're not familiar with his work, he's basically the inventor of calculus, although the British like to say it was Newton. I go with the Germans. And he has a very famous phrase where he says, music is the pleasure the human mind experiences from counting without being aware that it's counting, which is a great way of thinking about this idea of intuitive relationships to patterns. So he had this term, the monadology, and again, he's considered to be one of the philosophers who set the tone for rationality. And again, rationality goes to a root word, ratio, proportion, and again, pattern. So I was thinking about the idea of mathematics, nature, and sound, and then deriving compositions from that, and looking at Leibniz, and again, there's a kind of a Wagner here as well. Although I can unpack most of this, we have 5 minutes. I'm going to have to keep it really tight. 2 minutes. So you got, all right. So I'm going to give you the soundbite version. You can call it, AKA the hip hop Wagner. There we go. All right. This counter is okay. Well, there we go. Yeah, I know that's weird. There we go. All right. So the Italian futurists came up with this term of what we call the sound system. This is in 1915. This is what they called intono rumore. And they basically, the gentleman with the mustache coined this term, the art of noise, arte del rumore. And so essentially you would go to a futurist concert and the idea was to transpose an entire landscape in sound and generate a portrait of a city in hyper-accelerated motion. For me, what I'm doing is an update of that and thinking of sort of eco-futurism, but from the viewpoint of, again, data analytics and data aesthetics. And the idea here is we're looking at both resilience and remediation. How can we look at the patterns in disruption and think of them as sound, but also think of the sound as a way of perhaps creating a better and more robust conversation with the sciences. So I'm going to wrap up with this gentleman, and there's one last slide. This gentleman's name is Al-Khwarizmi. Essentially, whenever you do math these days, they derived the name algorithm from him. He was a mathematician in 9th century Baghdad. And basically, Fibonacci derived a lot of his work from his, they had this project called the Liber Abaci, which if anyone is into the history of mathematics, the concept of both zero and the idea of algorithms comes from the Arabic and Indian South Asian traditions. And I was intrigued by that kind of derivation of the way the Western concept of science and tuning systems had missed out on certain aspects of infinity and nothingness. And what's intriguing about this, I'm going to wrap up, is that that's a different composition. That's me doing brain waves, different talk. Sorry, different talk. Sorry, 1 second. All right, there we go. Up. Okay, so I'm going to wrap up with these two gentlemen. When Einstein got the Nobel Award, he was backstage with a gentleman by the name of Rabindranath Tagore. And Einstein, when he got nervous, would play violin. And he was quite good at Bach. He would transpose Bach's Goldberg variations, which many people tend to think of as very mathematical. And eerily enough, he would pace. He was a very talented violinist. There's actually recordings of him online if you ever want to do a quick Google search. So these two are backstage at the Nobel Prize Awards, and this gentleman is the first poet, Indian poet, to get the prize, and he was incorporating Sanskrit mathematics into his poetry. Einstein is, of course, getting the Nobel Prize for his research. And Rabindranath Tagore infamously says to Einstein, you know, you're playing violin, but you're playing all those Western tuning systems. Your music's all fucked up, you know. So you got to come to India and listen to microtonal music because we had the concept of zero before you guys. And so eventually they became good friends, and they had a correspondence, which again inspired me quite a bit for my compositions. What ended up happening is they wrote a book together called On the Nature of Reality, A Scientist Talks to a Poet. And for me, that's kind of my inspiration for working with this exhibition. And I could go on, there's a lot more, but I want to just give you the quick version. The physics of sound is very intriguing to me, and the way we can think about pattern recognition and nature in disruption is we're at a critical moment in what mathematicians would call a phase transition. And there's many other issues. If you want more information, all of the compositions and the math and everything is on the website. It's djspooky.com/Antarctica, easy to remember. And thank you for including me in the show. Thank you.
Okay, well, we have a little bit of time for question and answer now. So raise your hand if you have a question. I'm going to pass you the microphone. This is not that big of a space, but people on live stream won't be able to hear if you don't speak into a microphone. So please, both for the panelists and audience, if you want to speak, do it into a microphone.
Gavin, expressly a question to you, but please, anyone of the artists, since the last several COP conferences of the United Nations, we've had a tendency to see 2 degrees of warming as acceptable, moving beyond the 1.5. Can you make a comment, and not moving towards the emergency discussion we've already had before, but what does that mean from 1.5 to 2 degrees of warming?
That's a great question. And the answer is people don't really know. Can I just do a little quick poll, right? I mean, presumably people here have heard about the 1.5 and 2 degree limits that came out of the Paris Accord, right? That's almost everybody? Okay, good. Do you have a visceral sense of what that means? No. You see, so we have these targets that we talk about that are written down in these treaties, that are talked about in the media, but nobody really has a sense of what they actually mean, right? Are they big numbers? They don't seem like very big numbers. Are they important numbers? Well, it seems like it might be important, but how do we maintain that scale? How do we understand that scale? So I mean, the fact is that there's a massive disconnect between what people talk about and what people feel. Partly one of the reasons why I like to hang out with artists is because they can bridge that gap a little bit. But the essential piece of information that you need to put those numbers into context is, for instance, how cold it was the last ice age, right? So the last ice age, 20,000 years ago, where we are now would have been under, maybe a kilometer of ice. The ice went all the way from the Arctic Circle down to Brooklyn, Prospect Park. Actually, is the terminal moraine for the last ice age ice sheet. Massively colder. Sea level was 400 meters down. Mammoths, tundra, cave people. A very, very different planet, right? How cold was that planet? How much colder was that planet than the pre-industrial? Give me a number.
2 degrees colder.
Actually, so normally when I ask that question, people come up with very, very big numbers, and the answer is no. It was actually about 5-6 degrees Celsius, so that's about 8 to 9 degrees Fahrenheit colder in the last ice age, and that was a massively different planet. And so your 1.5 and your 2 degrees should be compared to the ice age. So we're talking a quarter or a fifth or a third of an ice age unit, but in the other direction. And where we may end up if we didn't do anything would be like a whole ice age unit in the other direction, as warm again as the ice age was cold. And that would be such a dramatically different planet. And that helps kind of crystallize, so what difference does 1/10 of a degree make? Okay, well, everything will change with every 1/10 of a degree, right? Things that are bad now in terms of extremes, in terms of rainfall, in terms of heat waves, they're going to get a little bit worse when we cross 1.5. They're going to get a little bit worse, perhaps a little bit more so at 1.6, at 1.7, at 1.8, at 1.9, at 2, at 2.5, at 3. Wherever we end up, right, every 1/10 of a degree is going to make a difference. So it's not... There is this inertia, which means that we can't turn around on a dime. We're driving like a super tanker or a Baltimore container ship, and you can see the metaphors are coming very quickly here. You can see the bridge in front of you, but you can't turn around in time. And we want to be able. Well, there we are. That was. So many sound effects, but yeah, I mean, the smaller we keep it, the faster we reduce the emissions, the happier we're all going to be. But I wouldn't get too hung up on exactly what number.
Thank you. I have a question. Whoever wants to jump in about. We talked about the gap between the knowledge of climate change and artists creating work. Do you think that art that's making a statement about climate change having an impact?
It's a funny moment because the idea of the imagination and what we can imagine is such an important thing. And what Gavin was just saying, I mean, I actually would love to differ with him on one thing, which is the fact that we can't necessarily give you a sense of the physicality. We can. Every street that you walk on in Manhattan was shaped and sculpted by the retreat of the glaciers. The Brooklyn, the rivers, every major system that we engage has been sculpted by the retreat of the glaciers, the Great Lakes, the coastline. Many of those things are going to be massively impacted by these things. But if the human imagination can imagine something, it's incredible that in a very short amount of time, I'm a big fan of this sort of doomsday clock that's been going with the Union of Concerned Scientists. They're very concerned. I think we're about 30 seconds from midnight at this point, or maybe less. But if we can imagine something, I think that's the first step to giving a sense of remediation and figuring it out. And that's where I think the arts have we need to have a better and more robust conversation with scientists. And I think that's what things like this exhibition are really helping do.
This is a question that's often asked of artists, and there is no way to measure it, but the typical response is always, we can impact emotions and, allow people to understand the issues in a way that facts and data cannot.
As a youngster in camp, I remember singing protest folk songs. We need our folk song leaders. It's not only the visual artists, we need the verbal artists as well. And I really do believe they can move people. Yeah.
This is for Mr. Miller. one of the things that I'm intrigued with is like, I don't believe scientists are going, I appreciate science, but I don't believe it's going to solve this problem, in that this problem for me is based in the economics that drives the market, so that the Koch brothers very effectively manage, is an example of like creating counterinformation so that it becomes a non-believable or not important. People react by their jobs and how they can create a living. So what I'm concerned about with artificial intelligence and so on is no one's mapping how much waste we are creating in these huge holding tanks for these data systems like, you know, whatever. Bitcoins. The same way as like the plastic, which is a byproduct of these fossil fuels, filling up our oceans, cutting off our you know, you know, if the animals don't roast, they'll starve. So that I'm interested in how do you change human behavior? And that job, I think, is part of art. So how do we get to that? So my question is, how do you get to a tipping point?
You know, thank you for your question. And again, to defer to Gavin, I think that facts, you know, don't care about our feelings. And I firmly believe that in the era of misinformation that we live in, anytime anybody's dealing with or grappling with climate misinformation and all of the political crisis that's going on, there's an algorithmic bias built into most of these social media platforms and all sorts of, you know, Elon Musk or whatever, Starlink, et cetera. Eerily enough, my motto these days is the imagination is the ultimate renewable resource. And the reason I began my talk by showing you this currency from the island of Yap, where Milton Friedman did his PhD, was the Saudi Minister of Oil for Saudi Aramco, which is one of the largest by market capitalization corporations in the world. He said, you know, the oil economy, let's think of it this way. The Stone Age didn't end for lack of stone. And so that's why I was showing you a Stone Age currency. It ended because people no longer needed the stone in that way. They came up with better ideas. So I'm a big fan of Buckminster Fuller and his sort of active, you know, the Greek term is called praxis, where you just apply this idea of innovation to make an old idea obsolete by coming with a better form. And I think there's so many solutions right now. When you're talking about data centers, companies like NVIDIA, which is driving a lot of the chips, microchips made for AI right now, they're already using AI to make more energy efficient chips, and given 1 or 2 generations of that, there's going to be tremendous benefits from just efficiency alone. And many of our buildings are built using terrible building codes, for example. And again, by optimization and rethinking that, you're going to be seeing a lot of innovation just in the next couple of years. I'm not a techno-optimist, but I do think when humans are put in a position of crisis, we tend to innovate. And that's, I think you're going to be seeing a lot of that. But meanwhile, we're trying to counter a multi-trillion-dollar narrative, you know. So that's a tough one to crack. Give a couple artists $1 trillion. We'll start from there. Yeah.
Okay, we'll do one last question. Sorry.
Yeah, I had a question for Gavin about the weird year last year. What was weird about it? What was different and weird?
So normally you can pretty much predict what a year is going to be like by what's happening in the Pacific at the beginning of the year, right? Or if there's been a big volcano or something like that. And up until last year, that was a great prediction. You know, you'd see what El Nino was doing, and you'd make a prediction, and every year it fell within the predicted bounds, except last year. Last year it fell way outside of that bound. So we're going, well, what's going on? And then you look at, you know, the pattern of how the El Nino, La Nina kind of pattern worked out. There were these massive anomalies in the North Atlantic and in the Antarctic Ocean, like literally opposite sides of the world, all moving in the same direction. Was that a blip? Was that is that connected? It was very unclear. And so when you look at the climate models, you say, is there anything that looks like that in any of the predictions? And the answer was no. Nothing had ever looked like that. So There could be other things going on. So that, people have been talking about changes in emissions from ships. People have been talking about changes in emissions from China. People have been talking about there was a very weird volcano a couple of years ago. Maybe that was having an effect. But we don't know. And when we've tried to quantify it, it doesn't add up. And so that's, as I said, disquieting from a scientific point of view, but I think also from a more general point of view, because, like I said, we don't want to be surprised by the climate. Like, our standard predictions are bad enough. Like, we don't want it doing anything worse than what we've already predicted it's going to do. So that's why. I mean, I'll send you the link to the piece I wrote. But yeah, that's why.
Okay, well, I know there are more questions, and I'm sorry to cut us off for a little bit over time. But so can we just thank our panelists so much for their time? I'm sure they'd be happy to talk further.